Hello, this is question 6 on paper 1 of TMUA 2017. So we're told that a particular tangent of this circle passes through this point 20, 0 and also crosses the positive y-axis. And we want to know where this tangent crosses the y-axis. So this circle is centered on the origin and has radius 12. So this is what that circle looks like. And we want a tangent that passes through 20, 0 and crosses the positive y-axis. So here's that tangent. Okay, so this point where the tangent crosses the y-axis is what we're trying to find. So let me label that as C. And I'm also going to label this distance between C and where it crosses the x-axis as H, because it's the hypotenuse of this right-angled triangle. And right-angled triangles are kind of the key in this, so we've already got one triangle with side lengths C, 20 and hypotenuse H. So by Pythagoras theorem, we have that C squared plus 20 squared is equal to H squared. And now if I draw in this radius to the point where the circle meets the tangent, because it's a tangent, this here is 90 degrees. And we have another right angle triangle. And even better than that, because this radius is 12. And this length here, which is actually the hypotenuse of the triangle, is 20. We actually have a 3, 4, 5 triangle. So this hypotenuse is 5 times 4, this side is 3 times 4, so this side must be 4 times 4, i.e. 16. And we also have a third right angle triangle over here. And okay, we know this length, which is actually the hypotenuse of this triangle, is C, and we know the radius of the circle is 12. And also because we know that this is 16 and this entire length is H, this side length must be H minus 16. Then by Pythagoras theorem again, we must have that 12 squared plus H minus 16 squared is equal to the hypotenuse, or C squared. Okay, so now we've got these two simultaneous equations for H and C, and I'm going to label them as 1 and 2. So let's expand 2 out first. Okay, so that's just by expanding this bracket out, and now we can substitute for this H squared by using 1. So that's just substituting straight in and then adding 1 for 4 and 2, 5, 6 to make 400 as well. And let's just tidy that last line up. So by cancelling some C squareds and adding the 2 400s up, we get that 800 is equal to 32H. And let's divide by 32 first. So we have that H is equal to 25. Okay, so now let's use 1 again to find C instead of H, but 1 has H squared, so let's square both sides of this first. Okay, and now we can substitute in using 1, so H squared is equal to C squared plus 20 squared. Then if we take the 20 squared, or 400, from both sides, and you might recognize 225 as the square of 15. So the tangent crosses the y-axis at y equals 15, which gives us answer B.